Sorry about that. I got a phone call and it cut my video off. All right, so what are the Pythagorean identities? Well, we have to remember something. The unit circle is a circle centered at the origin with a radius of 1. So the equation of the unit circle, if you remember, we've been writing it down quite a lot. The equation of the unit circle, because it's centered at 0, 0 with a radius of 1, was x squared plus y squared equals 1. Okay, that's the equation of the unit circle. So any ordered pair that falls on the unit circle, all of those ordered pairs with our special ratios in them, all of them have to make this equation true. If you take the x coordinate, square it, and add it with the y coordinate and square it, they will add up to 1. It has to make this equation true. That's what it means to be a point on that graph, right? All right, so if the point xy is a point on the unit circle that corresponds to the angle theta, then remember, if you're on the unit circle, then what did the x coordinate of that point equal? It equaled the cosine of that angle. Also, if you were a point on the unit circle, then what did that y coordinate equal? It equaled the sine of that angle. So if the x coordinates equal the cosine and the y coordinates equal the sine, then I can rewrite this equation, x squared plus y squared equals 1. I can rewrite that as, well, x is equal to the cosine, so I can rewrite that as cosine squared theta, because it is x squared, so the cosine function has to be squared, plus if y is equal to the sine of angle theta, I can rewrite that as y squared. I can rewrite that as sine squared theta, and then it still equals 1. So that's an identity. It's a statement of equivalence. I can now rewrite the equation of the unit circle in terms of cosine and sine. Now, I just want to talk about this for a second. Cosine squared theta means the function is squared. Cosine squared theta literally means cosine theta times cosine theta, right? The cosine of an angle times the cosine of an angle. It's cosine theta times itself 2 times, okay? It does not equal cosine theta squared. It's not the angle who's being squared. It's the cosine of an angle. It's the actual function who's being squared. It doesn't equal that. It equals this, okay? All right. So let me go off paper real quick. What we do to get all the Pythagorean identities is we just start manipulating this one. We just start doing all kinds of crazy stuff to him. So the first one is if I take cosine squared theta plus sine squared theta and it equals 1, the first thing you can do is just start solving it for sine or cosine. So guys, if I wanted to get cosine squared theta by itself, I could just minus sine squared theta away. And then I would come up with cosine squared theta equals 1 minus sine squared theta. Just minus him to the other side. So that's a Pythagorean identity. It's a statement of equivalence. All right. You could even square root it if you wanted to go farther, but normally this is the one we leave it as. So now cosine squared theta equals 1 minus sine squared theta. So if you're ever using a problem and you have cosine squared theta in it and you need to get sine involved, then you can take cosine squared theta out of the problem and put 1 minus sine squared theta into the problem. Or if you're ever working with a problem and you come across a 1 minus sine squared theta, you can take that expression out and put cosine squared theta in its place. We're going to use all of these identities to kind of interchange pre-written problems. So we can get one trig function out and another trig function in. All right, well, same thing. If I take this Pythagorean identity right here, I kind of call him the mom and dad. He's like the mom and dad of all the Pythagorean identities. They're all made from some version of him, right? He's the mom and dad of all Pythagorean identities. All right, well, what if I tried to get sine squared theta by itself? Then I could just minus cosine squared theta to the other side. So now we have sine squared theta is equal to 1 minus cosine squared theta. And that's another identity. So now we can say sine squared theta is equal to 1 minus cosine squared theta. Okay. All right. We have to get a little bit more creative to create other ones. So if you take the mom and dad, the fact that cosine squared theta plus sine squared theta equals 1. Well, what if you just said to yourself, because I'm sure you would, what if I just divided everything in the problem by cosine squared theta? So if I divided this by cosine squared theta, divided him by cosine squared theta, and divided this by cosine squared theta, what would you get now? Well, cosine squared theta divided by himself would be 1. Plus, well, if this was sine over cosine, who would that have been? It would have been tangent. Well, since they're both squared, it becomes tangent squared theta equals, well, if this was 1 over cosine, that would have been secant. Well, since it's 1 over cosine squared, it's going to be secant squared theta. And that's another one of your identities, okay? So write that one down. So 1 plus tangent squared theta equals secant squared theta, okay? All right, well, let's go back. Well, first, another one you could make right away is, what if you took tangent squared theta and you're like, I want to get him by himself. You could minus 1 from that, and then you would have the identity tangent squared theta equals secant squared theta minus 1. Okay? All right, now we can even play around with these two. So what if you said to yourself, well, what if I wanted to bring secant squared theta and tangent squared theta to the same side? So if I minus tangent squared over, I would end up with secant squared theta minus tangent squared theta equals 1 would be the only thing left on this side. So now that's an identity. So anytime you're working with problems and you see like maybe this expression come up, you could literally take this out and put a 1 in for this entire expression. These are all things we're going to be able to interchange when we come up with them. All right, well, look here. What if you were like, all right, well, this one is secant squared theta minus tangent squared theta. What if I minused him over? Then you come up with tangent squared theta minus secant squared theta equals -1 would be left on the other side. So there's lots of different little manipulations that could be made, okay? All right, well, the last two. The last two, we're going to go back to the original. Cosine squared theta plus sine squared theta equals 1. And again, if you can remember this one, you should be able to come up with the list on your own pretty easily just by, like I said, minusing things to the other side, dividing by things. You can come up with all your other Pythagorean identities. Well, what if you went back to the original and said, I think I'm going to divide everything by sine squared theta this time. So if I divide everything by sine squared theta, you get this. Well, cosine over sine would have been cotangent. Well, since they're both squared, you get cotangent squared theta. And then plus, well, sine squared theta divided by himself is 1 equals, if this was 1 over sine theta, it would have been cosecant theta. But since it's squared, it's cosecant squared theta. And that's one of your identities, okay? So now we have cotangent squared theta plus 1 equals cosecant squared theta, okay? And again, I could manipulate this one right here. What if I wanted to get cotangent squared theta by itself? I'd have to minus 1. So then you would have cotangent squared theta equals cosecant squared theta minus 1. All right, and then you can come back over here and you could play around with this one. Well, what if you wanted to minus cotangent to the other side? Then you would have cosecant squared theta minus cotangent squared theta equals, who's the only thing left over here? 1. And that's another version of that identity. And then I could come over here and take this one. Well, what if I minus cosecant squared to the other side? Then you would have cotangent squared theta minus cosecant squared theta equals -1. So again, all these are just manipulations that we've made from the mom and dad. The major, the big dog, cosine squared theta plus sine squared theta equals 1. All right. And now anytime you're working with a problem and any of these expressions pop up, this is something you'd be able to take out and put its equivalent written form in for that part of the problem. That's one thing that I feel like I said that bad. Sorry. Again, if you come up with this, he can come out, he can go in his place. If you see this in a problem, this can come out and that can go in its place. It's how we get one trig function out and another trig function in its place. And it still equals the same thing, okay? All right, I'll finish the back on my next video.